Welcome to Lesson 1, Year 11 Physics. First unit is distance, speed and acceleration. 5 units in total. Lesson 1 is pages 1 to 8 in your booklet. Learning objectives, I'll highlight now. An understanding of distinction between speed and velocity, and also being able to calculate speed and velocity. We'll also be using that equation. Okay, this is the booklet you're using. We number the booklet, page 1, front cover. The equation you'll be using for this lesson, shown at the top there, highlighted, is speed is distance over time, foundation tier. Same for higher tier underneath. Remember, those are the equations you'll be given with your exam paper next June. Okay, speed, distance, acceleration. What we know so far, you've already learned in school how to calculate the speed of an object. And we'll be reviewing that today and doing some more questions on it. To calculate speed, you need to know its distance, travel, and motion, the distance travelled by an object, and the time taken. This is a quick overview of the whole of this booklet, but for today, what we're going to be learning are these first 2, 3, 4 bullet points. Calculating speed, understanding that speed's a scalar quantity, velocity is a vector quantity, and velocity is also measured in meters per second. Just a bit of background there in the booklet, looking at what the fastest animals and measuring speeds. So I'll pick out a few points. Firstly, how we measure speed is in 90 meters per second is an example here. What does it mean? It means that every second that animal travels 90 meters per second. So that per second is shown like that in shorthand or in symbols. Now, on the bottom paragraph, there's a bit more information how to calculate speed. The important thing is remembering you need to know the distance and you need to know the time. So when calculating the speed of an object, what you've got to do is know the distance travelled and divide by the time taken to travel that distance. The fastest thing we can measure in terms of speed is that. It's the speed of light. Nothing travels faster. We need to rearrange equations sometimes, so this is always a useful tool to use. What it allows you to do is select the quantity you're trying to calculate. In this example, we're calculating speed is distance over time. If we wanted to work out distance, we multiply speed by time. And if we wanted to work out time, then again we isolate t, leaving d over s, or distance over speed. Speed measured in meters per second. Symbols like so, m over s. Careful with the spelling of meters, it's RES. And time is measured in seconds. Symbol S. Right, let's put that now into practice. Whenever you've got the question like this, you look at the numbers. Let's just read the question first. Usain Bolt, 100-meter world record holder. He ran it in a time of 9.58 seconds. Calculate his speed. Any of you that I taught in year 10, I like to make sure, in order to get full marks, you go through this 4-step system. Write down the equations, substitute the numbers, calculate the answer, state the units. ENAU, a little bit like Eno, hence the attempted drawing of a donkey saying Eno. Might help you remember, it certainly does help myself. So, equation. Distance over time. You put in the numbers. Distance is 100 times 9.58. Always good to use a ruler. Presentation important. Makes your work neater, easier to understand. Next, calculation. So we've done equation, we've done the substitute numbers. Let's get our calculator ready. 100 divided by 9.58. That is 10.4 rounded to 1 decimal place. And the units, remember, there. So if we were to summarize this, what have we done? Equation, substitute the numbers, calculate the answer, state the units. 4 steps, which gives you 4 marks. 1, 2, 3, 4. Apologies for the thick green pen. Okay, let's look at question 2. This time, it asks, if a bullet travels 300 meters per second for 2.4 seconds, how far does it travel? You've got to calculate the distance. The first thing you do is write down the correct equation. You can check up above for the right equation for distance. Okay, correct equation for distance is here. Speed times time. I'm not going to do any more of the question for you. I've highlighted the numbers in the question. I've put on a red asterisk as a reminder for you that you need to finish off this question. That's been scaffolded for you. And the last one, the only clue I'm giving you here is that you need to calculate time. I'm not going to tell you which equation to select. I'm sure you can work that out yourselves. Then on to page 7, read through. In short, what you've got to do is answer these 2 questions underneath. It asks, each animal finishes the 100-meter race. Use the data to calculate times the fastest, the slowest, and one other. Give the answer to 2 decimal places. Well, here's what I've done earlier. I've calculated the time for the fastest animal. So if you look up in the table here, the fastest animal was the cheetah. There he is. Fastest animal was the cheetah. What you've got to do next is calculate the time for the slowest. Now that could either be the coyote or Usain Bolt, because they've got exactly the same top speeds. Question 2. Oh, by the way, I put 2 asterisks here and here, telling you need to do 2 calculations. Question 2, explain why in reality the times for each competitor will be higher than those you've calculated. It's all to do with the fact that in our calculation we're using 31 meters per second for the cheetah, which is not his average speed, it's his top speed. Because if you think about it, when that cheetah starts running, he's not going to be running at 31 meters per second straight away. He's going to be starting from 0 meters per second. He's not going to hit his top speed until perhaps after a second or so. Okay, anyway, that's for you to answer. I expect 2 to 3 sentence answer with that. And if you need to, obviously just rewind this video, go back and listen to my explanation again. And finally, what is velocity? Velocity is very similar to speed. The only difference is, as well as it's got a size, it's got a direction. Another word we use for size is magnitude. I'll let you read that paragraph there, but if we look at these key terms, it says the velocity of an object is its speed in a given direction. New words, vector quantity has magnitude, that's size, and direction, scalar quantity, only has magnitude again. I'll write it down, that means size. So it's always useful to have an example. If we've got the cheetah running at a speed of 31 meters per second, that's not a velocity. To make it a velocity, we'd have to give it a direction. If we said the cheetah's running to the right at 31 meters per second, that's velocity. Your next task, write down what's the difference between speed and velocity. And finally, to finish off this lesson, lesson 1, a quick explanation again to show the difference between speed and velocity to help you answer the question above. If you had something travelling around a circle at constant speed, and it's travelling, let's say, 10 meters per second, you can see that its speed, yes, is constant, but its direction is changing. It's continually changing. And if its direction is changing, its velocity must be changing, because velocity not only depends on the size, it depends on direction. Okay, that's the end of lesson 1. What have you got to do? You go back through these pages and you make sure you've completed all the tasks with the red asterisks. Good luck. I'm sure you'll do fine. See you next time. Bye.